Hello everyone, thank you for signing in and watching my live stream. Welcome to Geometry. I am Mr. Matt and this is Dr. Tot. And today we're going to continue our discussion about triangle congruency theorems, or postulates. We have the angle, angle, side, the angle, side, angle, the side, 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 and the side, angle, side postulate. So we're going to go through those definitions one more time of the characteristics of each of those postulates. And then we'll look into some examples about identifying when those postulates are occurring and when you can say that two pairs of triangles are congruent or not. Let me share my screen with you. And just a reminder, because this is a live stream, there is a little bit of a delay with the iPad, but I'll be sure to stay on top of that as best I can. If you ever need me to scroll up or scroll down or go back over something, just let me know in the chat function or drop a comment below and I'll try and advise you as to what you might have missed or what the confusion is. But let's go through these postulates again. So first let's talk about the angle, side, angle. So the angle, side, angle, triangle congruency postulate. If two angles and an included side of one triangle are congruent to two angles and an included side of another triangle, then the two triangles are congruent. So for example, if we have triangle XYZ and we have triangle PQR. If we know that two angles, let's say angle X is congruent to angle P, and let's say that angle Y is congruent to angle Q, and then their included side length XY and side length PQ are congruent, this establishes triangle congruency because of the angle, side, angle postulate. But make sure that that side is the included side, and it's the included side in both triangle pairs. For example, if instead on this second one, if the congruent side was over here, was QR, that would not establish angle, side, angle congruency. That in fact would be side, side, angle, but because one is side, side, angle and the other one is demonstrating angle, side, angle, those are two different postulates, so they're not matching up, and therefore we would not be able to say that they're congruent. However, if we take that orange mark away, now they are congruent to each other. If you have any questions, then please let me know. Secondly, we have the side angle side congruency postulate. So if two sides and an included angle, so kind of the opposite of what we just went through, if two sides and an included angle of a triangle are congruent to two sides and an included angle of another triangle, then we can say the two triangles are congruent to each other. So again, if we have, let's say, triangle XYZ, and we have triangle PQR. If we know that XY is congruent to PQ, and we know that YZ is congruent to QR, and we know that the included angle Y is congruent to the included angle Q, then we've established that these two are congruent due to side angle side congruency. But again, they have to match up exactly. And you can tell because corresponding angles are opposite corresponding sides. So sometimes they might also represent these with actual values. So for example, if I back some of this out, if I gave you actual values here, so if I said that XY is 5 units long, and PQ is 5 units long, let's say that angle Y is 30 degrees, angle Q is 30 degrees, and let's say that line segment YZ where side length YZ is equal to 6 and side length QR is also equal to 6. So they don't have to necessarily tell you congruency through the congruency dash marks. They can also give you exact values, and as long as they're the same, you know that those the measures are equal to each other and the lengths are equal to each other. You know that the side lengths or the angle measures have to be congruent where appropriate. Okay, so if you have any questions, let me know. This again would establish triangle congruency through the side angle side postulate. The third postulate is angle angle side. So if two angles and a non-included side of a triangle are congruent to two angles and a non-included side of another triangle, then we can say that these two triangles are congruent to each other. So again, let's take XYZ and PQR. So if we know, for example, angle X is congruent to angle P and angle Y is congruent to angle Q, and side length YZ is congruent to side length QR, then we've established that these two triangles are the same triangle due to angle angle side congruency. Again, it's important to be able to match up that these two are exactly the same. For example, if I took away, let me take this out, if this last dash mark was over here, so if side length rather, YZ was congruent to side length PR, those do not match up, because notice that here the side length is next to the angle Y, which is congruent to angle Q, and over here the side length is next to angle angle P, which is congruent to angle X. So they don't match up here, so you need to make sure that they go in the same order. If you have any questions, then please let me know. The last postulate that I want to talk about is side, side, side. So if three side lengths of a triangle are congruent to three side lengths of another triangle, then we know that the triangles are congruent to each other. So obviously if I gave you congruency marks, that would be, they would clearly say that those lines are congruent. You just again need to make sure that they're in the same order. So this would show congruency because they're all in the same order and they correspond to each other. However, if I did this, now these are no longer congruent because they are in the opposite stereotypical position. So there's no way to rotate it, so I get those to match up. So be careful that they're in the same order. And also make sure that you understand that if they tell you that the angles are congruent, that's a totally different postulate. And that's a similarity postulate. That's angle, angle, angle. That does not mean congruent. Okay, so that only means that they're similar. That means that one, they have the exact same angle measures, but their side lengths are not necessarily congruent. Their side lengths are only proportionate. That means that there's a common multiple that you can apply to one triangle side lengths to get the side lengths of the other, but they're not congruent. They're similar, meaning that one is like a zoomed in or stretched out version of the other. Okay, if there's any questions, again, please let me know. Otherwise, let's look at some examples here. So I'd like you to determine whether the following pairs of triangles are congruent. If they are, list the triangle congruency postulate that supports your answer. So I'll give you 3 minutes. Please answer number 1 and then we'll review. I'll update the time every minute and keep track of it in the upper right-hand corner. Okay, so we have angle A is congruent to angle E, and angle B is congruent to angle D, and side length BC is congruent to side length EF. However, notice that the order of these two angles here are flipped around, so that does not qualify as angle side. If these were flipped and they corresponded exactly, then these would be congruent triangles due to angle side congruency postulate, but because they're opposite order, these are not congruent. If you have any questions, then please let me know. Otherwise, you have 3 minutes. Please look at question number 2. Okay, so triangle ABC, they're saying that the side length AB is congruent to something, BC is congruent to something, and side length AC is congruent to something. But in triangle DEF, they're demarking the angle measures. They're saying that the angle measures are equal to something. So if these two matched up to both be side lengths, and the side lengths were in the same pattern going around the triangle, then this would establish side. But because this triangle is talking about angle, which is similarity, not congruency, no, these two triangles are not congruent. If you have any questions, then please let me know. Otherwise, I'll give you 3 minutes. Please look at number 3. Okay, so because they say that side length BC is congruent to side length EF and the included angle C is congruent to the included angle F, and also side length AC is congruent to side length DF, we have side angle side congruency, so these two triangles are congruent. If you have any questions, then please let me know. Otherwise, I'll give you 3 minutes. Please look at number 4. Okay, so given this diagram and also the information that side length BC is congruent to side length DC, so this guy is congruent to that guy, and then the measure of angle BCA, which is this angle right here, is equal to the measure of triangle DCA, which is that angle right there. And then also, because they both share side length CA, CA has to be congruent to itself because CA is equal to CA, so side length CA has to be congruent to side length CA because it's literally the same segment. So we have side angle side congruency here. If you have any questions, then please let me know. Otherwise, I'll give you 3 minutes. Please take a look at number 5. Okay, so looking at number 5, we know that side length BA is congruent to side length DA, and then they tell us that line segment CA bisects angle DAB. So DAB is this larger angle right here. So if CA bisects it, that means that it splits it into two separate congruent angles. So then we know if CA bisects angle DAB, then we know that angle BAC must be congruent to angle DAC. Because overall, DAB is the summation of BAC and DAC. And so if DAB is split in half, the result would be two equivalent smaller angles. So if these two angles are congruent, and then also notice that both of these triangles share side length CA. CA is the same, so CA has to be congruent to CA because it's the same, because it's the same line segment. So therefore, we have side angle side congruency. If you have any questions, then let me know. Otherwise, I'll give you 3 minutes. Please look at number 6. Okay, looking at number 6, we know that CA, line segment CA, bisects angle BCD. So BCT is this larger angle up at the top. And so CA bisects that angle, so we know that angle BCA is congruent to angle BCA is congruent to angle DCA. And then they say that it also bisects angle DAB. That's this larger angle on the bottom. So then we know that angle DAC is congruent to angle BAC. Then we also know that the measure of angle CBA, which is this guy, is equal to the measure of angle CDA, which is this guy. So all the angles, they're telling you here that all the angles are congruent. But remember that angle proves similarity, not congruency. So we can't use that to prove congruency. However, we also know that CA is equal to CA. So actually, we do have angle, but that's not enough to prove congruency. That's only enough to prove similarity. However, we do have angle side angle. So these two triangles are congruent, but not due to angle, due to angle side angle postulate. If you have any questions, then please let me know. Otherwise, I'll give you 3 minutes. Please look at number 7. Okay, so side length BC is congruent to side length DC. So this guy is congruent to this guy. Then they say BA is congruent to DA, so this side length is congruent to this side length. And also remember, or notice rather, that they share CA. So we know that side length CA has to be congruent to itself. So we do have side, side, side congruency. So these two triangles are congruent to each other. If you have any questions, then please let me know. Otherwise, let's look at number 8, and this will be the last problem for today. Okay, so looking at number 8, if we know that side length BA is congruent to side length CD, and angle BCA, which is right here, is congruent to side length DCA, which is right here, notice, and they also share side length CA, so I'm going to highlight that. So CA has to be equal to CA. But notice that these guys are opposite corresponding angle measures. Triangles have strict angle to side correspondence, not necessarily proportionality unless they're similar triangles, but that's where you open up into trigonometry. Trigonometry is the mathematical study of angle to side correspondence with triangles. Notice that opposite, you can define an angle or a side, I should say one way and then the other. You can define a side by its corresponding angle, or vice versa. You can just define an angle by its corresponding side. Notice how these congruent sides are not opposite the congruent angles, so they don't match up. So these two triangles are not necessarily congruent. They may be, but we can't prove it as it's listed here. If you have any questions, then please let me know. Otherwise, thank you guys very much for watching my live stream. If you find these videos helpful, then please like the stream and subscribe to my channel. I appreciate it very much. Otherwise, Dr. Tot, do you want to say goodbye to everybody? I think you've earned a cookie. Come on, you better get your cookie. Come on. You say goodbye to everybody? Can you say bye? Can you say bye? Come on, you can do better than that. We're very tired at this time. Thank you guys very much. I'll talk to you all soon. I hope you have a wonderful weekend.